Hello everyone, I am here to present my topic salary prediction of the data professions. So first we will be looking at the data description. The dataset consists of 2,639 entries and 13 columns. This is clearly a regression problem and we will train the regression models to predict the desired outputs, and we are looking at the summary of the columns. So there are 13 columns, and first column is first name, then last name, sex, date of joining, current date, designation, age, salary, which is our target variable, unit, leaves used, leaves remaining, ratings, and past experience. So our problem statement is salaries in the field of data professions vary widely based on factors such as experience, job role, and performance. Accurately predicting salaries for data professionals is essential for both job seekers and employers. Based on the problem statement, it's clear that we have to create a supervised machine learning regression model as the target variable is continuous. So first we are importing all the necessary libraries used for our project, and we are loading the data. Now checking the shape of the data, we are having 2639 rows and 13 columns. So looking at the information of the data set, we are having, we can see the column, how many columns are there and how many nominal values are there, and also we can see the data types, that is D types of the given columns. So there are object, float, integer and all. Now we are checking the unique values. This is the code that we are looking for finding the unique values. Now describing the data set and checking the duplicate values. So there are 161 duplicate values present. So we are using drop duplicate the code to drop the duplicate values. Now again we are checking the shape of the data, that is after removing the duplicate values we are having 2478 rows, others are removed. And now we are going to convert the date columns to datetime objects. This is the code that we are using for that, and we are extracting, so from this column we are extracting the year from the date column, so we can check if it is correlated to the salary column. Now we can see that the first name and last name would not have any predictive power for salary, so it can be excluded. Also remove the column date of joining and current year, since we have created an extra column date of joining year and current date year from the columns date of joining and current date. Now we are dropping using the drop function. Now we are handling the missing values using the isNA function. We are looking the missing values and filling the missing values using mean, mode, mean and mode. Now all the missing values are filled. Now our data is clear. Now we are going to check the D types, that is sex is object, designation that is also object, and we are having some categorical columns. So we are finding which all columns are having categorical values, that is sex, designation and unit are having categorical columns. Now we are looking at the distribution of target variable. So looking at the distribution of target variable using the bar chart, since our target variable is continuous. Now we are going to the exploratory data analysis, that we are having sex chart, then designation, then we have done the line plot of average salary by year of joining. Then we have done the exploratory data analysis of average salary by designation. We have done the pair plot of the entire data. From this we can understand there are some outliers are present. So we are checking the outliers using the box plot method. We are finding if there are outliers are present or not. So we can see the outliers are present in the column past experience and the age column. Now we are using the interquartile range to remove the outlier from our columns. So after removing the outliers, we can see our data is clean, and calculating the correlation and the heat map, we will be seeing the ratings and date of joining year and current date, which are not correlated with the target column salary. So we are removing the columns ratings, date of joining, year and current date year. After removing all the columns, we are having sex, designation, age, salary, unit, leaves used, leaves remaining, and past experience. Now we are continuing with the data pre-processing step, that is encoding all the categorical values using label encoding. So we are using label encoder for label encoding. Now we are resetting our the index, and we are using the feature selection method, that is ANOVA is used for the feature selection here. And using the select k-best, we are selecting 6 columns that are needed for our further proceedings. Now we are using model creation, that is we are using 5 algorithms, that is linear regressor, decision tree regressor, random forest regressor, and ADA boost regressor, and k neighbors KNN regressor. Now we can see that after all the creation, model creation, we can check the R2 score of these models. So we can see the best model as ADA boost regressor is having the best accuracy score, that is R2 score. So comparing these models, we can see that ADA boost regressor is having the top performing model achieving the highest R2 score.